Hello, I'm the Southern Frontier, and welcome to another video. Today we will be going over recursion and how this is implemented in LEGO Mindstorms. What is recursion? The most simplest definition of this, at least that I know of, is when you call a method from the same class. I'm referring to this in the form of Java. However, this is used in pretty much every programming language. But mainly I use Java, and in that case we call it a method. This is a basic example of a recursive function. So, let's see, laser pointer. So, recursive functions, and this is the name of it. It has an input, which is represented by an X here. So, for example, if you were to put in a 4, it would go in and would say, and it would check to see if x is equal to 0, and if it is not, it will call itself, this is a call, and it will say x minus 1. So if it was 4, it would subtract 1 from it, and it would become a 3, and then it would loop up to here once again. So now it's 3, it checks, is it equal to 0? No. Subtract 1, goes back up here, x, is this true? Does it happen this time? It does not happen, because x is still not equal to 0, so it subtracts 1, and at that point there is 1 left, it checks again, x still does not equal 0, so it checks one more time, and now x equals 0, so it returns. Now in some cases it will return a number. Not all recursive functions look like this. However, in this case this is just gonna return nothing. So, how do you use this in Mindstorms? There is some issues behind it, but the most simple form, at least that would work, is this. When you start a program, it writes start at line 5, waits until you press the center button, then calls the myBlock method 1. This is the myBlock method 1. It clears the display and waits until the button has been unpressed, and it writes 1. Then, when you press the center button, it goes to 2. At 2, it clears the display again, waits until no button pressed, and then writes 2 at line 5. And then it waits until the center button is pressed again, and then it calls 1. The issue is that recursion doesn't exactly work the same way it does in Java or in other programming languages. So let me pull out a notepad here so I could help describe this. So, when you start this program, what happens? Well, it writes start at line 5. So let's go down 1, 2, 3, 4. 1, 2, 3, 4, 5. And it says write start. So write start. And it waits until the center button is pressed. Now go to 1. Goes to 1, clear the display. So now, done. Write 1 at line 5. 1. Wait until the button is pressed. I press the button. Clear the display. Wait until no button pressed. Now write 2. See, it's all fine so far until you press the center button again and it calls 1 again. For some strange reason, I don't know why, LEGO Mindstorms EV3 Classroom, Education EV3, does not allow for recursion. Now, my assumption would be that because this is usually made for the kids, this is the education edition, most people end up doing stupid things. For example, they might end up causing an infinite loop, which will overload the storage space. And by this I mean that it can't run anymore because there's too much data and it can't clean it out. Another reason might be that they never coded in for that. However, there is somewhat of a way to get around this. You have to do something here. So you remove, let's just clean this up a bit. So this is going to call itself from now on. So I'm also going to tell it, let's say, to make a beep sound for 0.2 seconds every time it runs. Now, instead of this 1, we are going to create a variable. This variable will be called, let's see, 1 loop. And we're going to just put a set here. We're going to have a control. Repeat. You're going to want to have it equal something. Now this condition I'm making is a Boolean, or a 1-bit operator. This contains either a 0 or a 1. In this case, it will be a 1. And it will repeat until that happens. So, we're going to also make a second variable. Now this is not necessary, but I want to make it a bit more understanding. So let's say display number. So we're also going to set the display number. We're going to set to 10. And every time we run this, we're going to tell it to write the display number and change it by -1. So what happens here? So let's pull this out. Sorry. Let's pull this out and remove it. So what happens? Well, first of all, in the data storage area, I'm going to refer to it by using these lines. So this is some 2 bits of data storage. So first it says, alright, display number. We're going to make that equal to 0. Now what about 1 loop? We're going to make that equal to 10. Sorry, 10. Now what happens when we run the program? Right, start line 5. 1, 2, 3, 4, 5. Start. Wait until the button is pressed, and from then on, it's going to repeat this until 1 loop equals 1. Wait a minute. Oop, my bad. Let's try this again. So when it starts, display number equals 10, while 1 loop equals 0. My bad. But when it starts, it goes down 5 lines. 1, 2, 3, 4, 5. And then writes start. Waits until the center button is pressed, and until 1 loop equals 1, it's going to repeat this my block titled 1. And every time it's going to clear the display, wait until no button is pressed, and then write display number at line 5. So what happens right now? Well, was display number? It is 10. So we put down a 10. The program writes down 10. And it removes 1 from display number. So now display number is 9. And after you press the center button, it'll make a beep sound. And now we have recursion to a degree. it's going to go up here. One loop is not equal to 1 yet, so it does 1 again. It clears the display, waits until no button was pressed, and then writes the display number. So now, you're going to output 9. Now remove 1 from display number, and then do it again. Until, over time, it ends up going down and down and down until... Ooh, I forgot something. In Recursion, you need an if statement. This is required. Because without the if statement, it will repeat forever. And that is part of the reason why Mindstorms doesn't want that. Because some people will include this and it will repeat forever. It's not always the worst thing in the world, but it's something that they don't want to have to deal with, you know? So display number equals 2, 1 loop equals 0. And then we're going to make a condition that says if display number equals, let's say, 1, then go ahead and change the 1 loop by 1. So now what happens? Well, it keeps going down and down and down until u equal 1. Now it's going to run back through. 1 loop is still equal to 0, so it does this again. Clear the display, wait until no button pressed, write the display number, write 1. And now it checks, is display number equal to 1? It is, so it increases 1 loop by 1. Waits until the button is pressed, makes the beep sound, and it checks one final time, is 1 loop equal to 1? The answer is yes, so it stops the loop, and it's done. That is the most basic form of recursion. Now there are other ways they do it, which would be to then take this number and use it when it's going out. So, for example, let's add this old block. Now, this is the creation menu for the block. You can put a title here, and then you can get rid of it or whatever. You can put an input, which is a Boolean, or you could add a label or an input. And these inputs are numbers or text. So let's say that. And clear this. Save. Now we have this. And we're going to tell it to run with that. There is an issue with this one, and that is due to just how it works. Now we can fix this simply by putting in a variable, such as display number. We'll put in 10, and this 10 we'll put in, it'll write this number. And then we do display number -1, and it will do the exact same thing. But sometimes every time it's going to return back display number. It's going to make it this thing here, and it's going to write down the number. It's the exact same thing as before, but this time is returning this number every time it finishes. Now earlier I mentioned some of the issues behind why they didn't want to go ahead and put in recursion. Now, I don't know the Mindstorms community well enough to say that, yes, this is definitely what they believe, this is what was required. Like, I don't know that, but one of the obvious beliefs, as I said, was that a lot of people will accidentally make infinite loops, and they won't know why, and then things will end up being very annoying to them. So let's go ahead and create an example of that. Let's clean this up a bit. There. So now, we put this here. That's a weird glitch, but it's fine. So now, what happens when I go ahead and remove you? One loop will never get updated. Forever and ever and ever, this one loop will stay equal to 0, and this number will keep getting smaller and smaller and smaller until eventually this thing breaks because the number gets too big. And just to show a bit more, I'm going to remove this, and then I'm going to show a video of me going ahead and doing that, so you can see why it's not a good idea. Alright, well, I'd like to thank you for watching this video, and I hope you have a very nice day. Hope you learned a bit about recursion, and have a good day.